Hello everyone. In this video of Vedic Maths, we will be learning about a concept known as digital sum. Digital sum refers to the sum of digits of a number until we get a single digit. This concept of Vedic Maths can be easily understood by students of class 9th and above. Now in this video, we will also discuss the applications of digital sum. Let us know what is a digital sum. For example, we have a number say 124. To find the digital sum of 124, we will add the digits of the number. That means 1 plus 2 plus 4. Adding them equals 7. So the digital sum of 124 is 7. Let's take another example. The digital sum of 38. Now in this case, 8 plus 3 is 11, which is a two-digit number. Now to get the final answer, I will add 1 plus 1, which becomes 2. So the digital sum of 38 is 2. Now there are a few points to be remembered while calculating digital sum. The first is whenever we are adding two numbers and we get a sum equals to 9. Now this 9 is treated as 0 or we can ignore this 9. Also, if we have a number that sum is 9 only, we will see an example in the next slide. But if we have a number whose final sum equals to 9, now in that case we can't say that the digital sum is equal to 0 because practically when we add two numbers together we cannot get a sum equals to 0. So this is an exception in which the digital sum is 9. One more important point to be taken care of is digital sum is not valid to approximate values. Let's see an example. For example, we have a number, say 543241. We need to find the digital sum of this number. There are two ways we can do it. The first is the normal method in which we are adding all the digits of the number. 5 plus 4 plus 3 plus 2 plus 9 plus 4 plus 1 equals 19. Now 9 plus 1 equals 10 and the digital sum of 1 plus 0 is 1. So the digital sum of this number is 1. Or what we can do here is by looking at the number, we can see that 5 plus 4 is 9, 3 plus 2 is 5 and 2 plus 4 is 9. So now all this becomes or can be counted as 0. So my final answer or digital sum of the number will be 1. One more example. In this example, we have number 1845 and the digital sum of this number is 9. Now in this case, we cannot say that my sum is 0 and ignore the 9. The reason behind is we cannot add two numbers and say we did get sum 0. So in such a case, the digital sum is 9. Let's come to the applications of digital sum. The first here is checking the answer. That means with the help of digital sum, we can check whether our answer is correct or not. Now here one thing to keep in mind is if our digital sum of the answer is equal to the digital sum of the numbers, then we can say that our answer may be correct. But if the digital sum is not matching with the answer, then we can definitely say that our answer is 100% wrong. So there is a situation. Now this means that if digital sum does not match, then the answer is 100% wrong. But if the digital sum matches, then we can say it can be right or it can be correct. Let's see an example. Here we have 6541 that we will be adding with 843. The digital sum of 6541 is 7 and the digital sum of 843 is 6. Now since we are adding these numbers, I am going to add their digital sums. 7 plus 6 equals 13, 1 plus 3 equals 4. So the digital sum of my numbers is 4. Now the answer after adding these numbers is 7384. That means the digital sum of this number is 4. So whenever my answer is correct, my digital sum will match with the numbers. This is a case where my answer is correct. Now let's see another example. Here we will be subtracting 874 with 214. Now when I write the digital sum of my subtrahend and minuend, the digital sum of minuend is 1. The digital sum of subtrahend is 7. 1 minus 7 will be minus 6. Now to make it positive, I will add 9 to it to get the final digital sum as 3. Now, this 606 is a wrong answer. But what we see that the digital sum of 6 matches the digital sum of numbers. That means that even if the digital sum is matching, we cannot say that our answer will be 100% correct. We can say it may be correct. So the correct answer is 660, whose digital sum is also 3. Let's see a case where our digital sum will not match and hence our answer will be 100% wrong. In this case, we are again adding two numbers, 4876 with 3412. In this case, the digital sum of the numbers is 8 and the answer, which is the wrong answer here, we can say its digital sum is 3. Now since the digital sum of my answer is not matching with the digital sum of numbers, this answer is 100% wrong. There is one more application of digital sum, that is percentages. Now if we want to find the percentage of, say for example, 30% of 500, the conventional way to do is in this format. Now using Vedic Maths trick, what we can do is, we can do 30% of 500. We can multiply 3 and 5 together, that is 15, and add decimals after 2 decimal places from the right hand side. I hope you understood the method. Thank you and stay tuned for more such videos.